And one of the files is comparable.java, and it has that code that's similar to what you see there in that file. Defines the interface, it has the generic variable, and then you have to implement a method called, if a class implements comparable, that class must implement a method called compared to that returns an integer. And then whatever the generic variable is, that's the parameter type to the method. So this allows us to compare objects that are instances of the same class. So we build it right into the class. Like the string has a compare to method, and it's whoever wrote the string class and what was one time owned by Sun Microsystems. So I think they wrote all the original code. So strings are sorted in alphabetical or dictionary ordering. So we've compared the first two characters, and really which one has the greatest ASCII value. Okay, and so lowercase characters like lowercase a through lowercase z have ASCII values of 97 through 122, and I think that for uppercase it's 65 through 90. Yes, all the lowercase characters have a higher ASCII value than the uppercase characters. So, and those are the only ones I know. And you can, so if you want to know the ASCII value, so every character on your keyboard has actually maps to an integer, like an ASCII value, and you can just go online, get an ASCII value chart. But, I'm not sure that it's that exciting. I think what's important to know is these characters are mapped to an integer. Okay, so here's an example, a little bit small. Can I make this bigger? So there's the code. So we did this before. We had assignments on it and quizzes on this where a class implements comparable. And so what we're doing is we're saying the larger the radius, the larger the circle object. So, and it doesn't have to be that way, right? So it's this, we decide what it means for one object to be bigger than another. We create that rule. But the one thing that we're kind of stuck with is this method called compare to. So this is the agreement that we've all made. We're going to compare objects with compare to. No one asked us, but it's not really a democracy. The programming world is not really a democracy. I guess it's whoever came before us and whatever. I don't know. Is it really that important? Okay, but anyway, okay, so we're stuck with this method called compare to. And what we're doing is we're comparing the current object, which that's this, with the input parameter c. So this always, so like in the main method, this is the calling object. It's like you always go object dot. So the object is this. So so if you go like object dot compared to c, it's the object that comes to the left of the period that maps to this. Okay, so this we've seen before. This code like this. So now I'm going to maybe make this tinier with this. Okay, so let's say, so again, here's a simple example. Okay, so just this is a reminder. So let's say we create 3 circle objects, and okay, so the way we wrote it is that the larger the radius, the larger the circle object. So let's just go C1 dot compared to C2. Now in this case, in both those examples, C1 is this. Like on the previous slide, we go, because it's the object that's actually the calling object. So that's this. So it's this dot radius minus C dot radius. Okay. So C1 compared to C2. So we just go this dot radius minus C dot radius. So it's 8 minus 6. We get a positive value. And so by our rule, remember, if the compare to method returns positive, then this is greater than the calling object is greater than the input parameter. That's the rule. Yeah, I'm not just making it. That's the kind of, it's also not obvious. It's just, again, whoever made all this compared to stuff up made that rule for us. And so we've all, we've all agreed to use it. No one said, hey, let's change the rule. I don't like that. Yeah, I don't think there's like a big movement to change the rule. Yeah, there's too much code and it all works. Okay, so if you look at the second example, C1 compared to C3. Yeah, let's write Sun Microsystems. No, let's write Oracle and tell me we want this changed. Yeah, I'm sure. What kind of letter would we get back? Okay, but I'm digressing. Okay, so C1 dot compared to C3. Okay, so in this case, the radius of C1 is 8, and the radius of C3 is 10, and we subtract 8 minus 10, we get a negative number. So according to the rule, if compare to returns a negative value, then the calling object is less than the input parameter. So in this case, C1 is less than C3. It's kind of, this would probably be a good rule. The larger the radius, let's say if we're trying to, order circle objects, which ones, because that's how you sort. You have to say what's, you have to compare two objects and decide which one's bigger. So this kind of might be a good rule. The bigger the radius, kind of maybe is intuitive. That makes sense. But it doesn't have to be that way. It could be the smaller radius is the bigger object. And since this class only had one instance variable, that's probably the only way to really compare objects. Circle object. Okay, so then there's this. Now we're going to look at an example in a minute. There's there's this built-in class in Java. It's in the java.util library. There's a class called arrays. It has all these kind of what are called static methods, these built-in methods that allow us to do these kind of useful things. Okay, and so it's actually we're going to see that this sort method, arrays.sort, it's an overloaded method. So if this is a classroom and I wasn't the only one here, I'd say, okay, who can tell us what an overloaded method is? And then maybe there'd be like a moment of silence and someone would reluctantly raise their hand, maybe give the right answer. Okay. And then, so an overloaded method is when you have different versions of the method. The method name is the same, but the parameter list is different. So in this case, this version of sort takes one parameter and it's array of type comparable, right? And so we're insisting that every element of that array, implements the comparable interface. And we're assuming we're not really doing the checking, so we're kind of assuming that that all the objects are from the same class. And in our course, it is. We'll just keep it easy, like that. Okay, so we're kind of violating the rules of generics by we're not actually using generics. If we did, then the coding is a little more when you use generics and static methods, it's just more complicated. So I'm keeping it real simple and I'm taking the generic out. So we're just going to assume that every element of that C array is of the same class. Okay. Okay, so we're going to use the rule in the compare to method to sort an array of comparable objects. So that's what arrays.sort does. It takes array of type comparable, and then it's going to, which one's the smallest? So it scans that whole array and tries to find this. If we were using a selection sort. Actually, what it does, it actually uses, I think it uses some variation of quicksort. Or there's another one where it uses either quicksort or merge sort, and which we haven't learned yet. Okay, okay, so like in that main method I have, and then we'll actually look at this. I have the code. We create 4 circle objects and we're going to sort them. And what it is, so let's actually just look at this here. And here I'm going to stop sharing this for a second. And actually I put the code online. Okay, so then we should see, okay, what we see is I'm not done grading homework 3 yet, in case anyone's wondering. It's taking me a long time. Okay, so here's the circle class. And I'm not sure if that, I don't really quite understand. I'm not an experienced Zoom user. I know I'm getting blocked a little bit by Zoom, what's on my screen. So I'm just going to push that down a little bit. So that's the code that I have in the PowerPoint slides. And now let's look in this file called test circle. Okay, here, so do I have, let me just review what I have here. Okay, so, okay, yeah, so I don't have the comparator in yet. That's fine. So I'm going to just comment this out. And then, yeah, sorry, I was lecturing you. I mean, I have another section and this is code. I was a little confused. I forgot to take the code out. Okay, so I don't think you see this code online. I'm going to put some code in. Okay, so in line 12, I define an array of circle objects, and then I'm just going to sort them, right? So if we were going to print it out in the way they were originally defined, the radius it'd be 8, 6, 102. Now the thing about arrays.sort, it's going to permanently change the order. So if for some reason you need the original order, and you need to save a copy of the array. So arrays.sort is going to use our compare to method that we wrote. So that's what arrays.sort. It goes into our circle class and then uses that rule, right? Because each one of these objects has a dot compare to method. There's nothing wrong. So the sort method is guaranteed. When it let's say, let's say tries to compare the first two elements of that array, the compare to method is defined. You're not going to get like a runtime error. Oh, method not defined. Okay, so now let's just run this. Let's see what happens. Yeah, and there we can see that arrays.sort actually sorted it using our rule. And if I want to, we can go, I think we've done this before. I can just change, I can just put them, go c.radius minus this dot radius. Now I'll go back when we'll sort one more time and you'll see without actually, so this is all, the only change we made here is right there. We go back to our test circle class, and then if we run it again, you'll see that the sorting is reversed. So the largest radius is actually considered to be the smallest object. So the first one printed, it goes from smallest object to largest object. So the bigger the radius, the smaller the circle object. And that's just based on our rule, right? Because I changed the rule. So we changed the rule right there, in case you stepped out of the room for a minute. So just to show you that. Okay, so let's go back to the original rule. So this rule is that it returned a positive number when this dot radius was smaller than c dot radius. So let's just go back and do the original. So now students, now comes a very exciting part of the lecture. So I'm going to, I'll stop sharing here. I think I'll go back to the slides. Okay, so okay, suppose we want to so we have like the we have like this circle class, we have this built-in rule. Okay, so let's say, oh, we love this circle class, someone gave it to us. We don't actually have the code, all we have is the bytecode. But we don't want to write our own circle class because this circle class is so perfect. Why would we want to write a different circle class? Except maybe we go, oh, you know what? I like everything about the circle class, except I don't like how it compares circle objects. I don't like how it's, the bigger the radius, the bigger the circle object. Okay, now that's, circle classes are easy to write, but let's say the string class. Oh, we want to order strings in different order. We're not going to write our own string class. The string class has got lots of stuff in it. I mean, it's actually a hard class to write because now basically a string is an array of type car. Yeah, there's a lot of stuff in there. Okay, we don't like to write. Okay, but so we don't want to write our own string class, but maybe we don't like the compare to method in string. So that's the whole point. Okay, so we got this circle class. We love the circle class, except we hate the compare to method. It's like we can't sleep at night. Oh, what can I do about that compare to method? And then oh, the comparator interface comes along. It's like, oh my God, it's like our life is a lot better now. Okay, so the comparator interface allows us to make up our own ordering rules. So we can take any class in the world that we want, and the original class doesn't even have to implement comparable, but we can make up our own. So someone gives us a class, maybe we don't have the source code. All we have is the bytecode, but we still want to be able to order compare objects. Either we don't want the rule that's the default rule that's defined in the compare to method, or maybe the original class doesn't even implement comparable. Okay, so there's this interface called Comparator, and it's also defined in java.util. So like, let's look at this. And so you actually have to write a class for writing. I'm going to show you how there's a way of getting around writing a class that implements comparator. But here is, there is how the comparator interface is defined. Again, it's an interface. So if you actually, and again, it's built into the language. You install the Java development kit, you get this compressed file, comparator.java, and it's in the folder java.util. It's in the folder. So if you actually use Comparator anywhere in your code, you have to go, you need an import statement, java.util.comparator. Okay, so this is what the comparator interface looks like. Once again, we're using the generic variables in that diamond operator E, and now we're comparing two objects from the E class, whatever, we pass in E, it represents a class name. And so now, unlike Comparator, which just takes one variable, one parameter, this takes two. And we're comparing object one and object two. Oh, hello, Julio. I'm just kind of recording this. So I'm talking about the comparator interface. So you came about the right time. I just started, I kind of was giving some justification for the compare. So we talked about the comparable interface. And now I'm talking about and I just started talking about the comparator interface, which is a way of comparing two objects from the same class. So suppose we don't actually have access to the source code, so we can't actually either implement comparable, or we can't change the comparable method. We want to compare two, we want to make up our own rule for defining how to compare two objects. So we use this thing called Comparator, and that's all I'm talking about, right? So I'm not really talking about a lot today. And next time I'm going to talk about quicksort. Okay, but here's the interface. To use it, you actually have to import java.util.comparator. And it has this compare method. And I was just about to say, how does this compare method work? Okay, and it's really very simple to use. I'm going to show an example, a couple of examples. Okay, so so let's say, what does it mean for one object? So the compare method tells us if one object is bigger than another. Okay, so if compare object one comma object two is positive, then object one is considered to be greater than object two. And that's just something, that's not obvious, that's just some agreement we all made a long time ago. And if compare object one comma object two is negative, then object one is less than object two. And then sorting methods will use this rule here. How does it, so sorting methods will need this compare, because sorting methods will, they have, sorting methods just have to decide is one object bigger than another. So sorting methods can use this compare method to decide which object is bigger. Okay, so now, so one thing is that let me just quickly go back for you. So this PowerPoint slide is online. You go to lecture 12, you go to files, lecture 12. And then you'll see I have a few files for this comparator. So I'm just using the PowerPoint slides from that lecture. So I'm assuming I have this circle class, which is back, really something I could write in Math 130. It's a little hard to see. So I'm just using this circle class right here. And there's the built-in compare to method. But the important thing to know about this circle class, it has one private instance variable that's defined as radius, and it's integer. So all it is, we have just a circle class, private instance variable that's radius, and a get method and a string method, toString. Nothing too exciting. Okay, so then we're talking about this interface called Comparator. So remember, when a class implements an interface, it has to actually define that method. So if a class implements Comparator, that class better have a compare method. Yeah, and so this is what it means for one object to be bigger than another. We just talked about that. Okay, so let's look at this. I want to write the compare method so that the smaller the object with the smaller radius is the bigger object, and that's up to us. So the only thing that's really creative that it's this part with the return. That's the rule that tells us if one object is bigger than another. Okay, so in this case, C2 is the second parameter, C1 is the first, and C2 is the second. We're taking the difference of their radius. But notice we're going C2 dot get radius minus C1 get radius. And that's positive, right, when the radius of C1 is less than the radius of C2. Right, so you subtract a smaller number from a larger number, you get a positive value. So that's positive when C1 has the smaller radius, right? So So compare C1 comma C2 is greater than 0 when C1 has the smaller radius. So in my circle class had that, so it's just the opposite of my circle class. The circle class had that built-in compare method. That's how we wrote it. Oh, really made it too big. Right there is the opposite. There, compare to returns positive when the current radius is bigger than the radius of the input parameter. And we'll go back to, okay, so then, so what do I want to talk about? Okay, so let's actually, I had some Java code there. So let's go, I'm going to share Eclipse, but do you have any if you have a question that's not related to this, let's just talk about it after I'm done, and I'll definitely do that. But do you have any question right now about Comparator or anything that I know you came in a little bit late, but I just started talking about Comparator when you logged on. If you have any questions, just shout out or just chat. Okay. Also, just make sure you're aware I'm recording this. So yeah, okay. So let's see here. Okay, so okay, so this isn't really, it's a pretty short lecture today. I didn't want to introduce too much new material. This actually is not in the Zybook book. Okay, so let's go back. So there's that circle, that class I just showed you, the circle comparator class. It has that method. It has the compare to method. So, and that's what if a class implements comparator, it must have a method called compare. So if it implements comparator, it has to have that method called compare. And that's the only reason we're creating this class, is to get that compare method. Notice that class doesn't do anything other than implement compare. So the only thing that interesting that we add is what's after the return. It's line 14. So like if I said a class is going to implement comparator, the integrated development environment could actually generate most of the code for us. It could put in the import statement. It can actually put in the method header, public int compare. It could put public class. Well, the class, it has to give some class name. That's, that's a choice we make, but that's not so exciting. But then after, then the header has to end with implement comparator circle. So really, it's just this line. This is the only part here. So we define the rule for ordering. So it's this line 14 that's really the only thing that's interesting about this class that implements comparator. Okay, so let's go look at the main method now. I have a main method called test circle, and yeah, so we define a bunch of like line 12. I define an array of circle objects. So one, radius 8, radius 6, radius 100, radius 2. And then what I think we've looked at this before. We have an array of circle. We have this method, built-in method, arrays.sort. So that arrays class is in java.util. So I need the import statement. Line 8, it says import java.util.arrays. And then and you need that because the class called arrays is in java.util. The full name of the arrays class is really java.util. So you just put that import statement, allows us to use shorthand later on. And it has that built-in method sort, which actually sorts an array based on, if you put in one parameter, it uses the method defined in the compare to. Because there's actually different versions of sort. Some where you just put in one parameter, and then there's one where you use two parameters, and then the second parameter here. So I'm just going to uncomment the rest of this. And here I'm going to move this up here and just keep that as a comment. Okay, so the first time we're going to sort using that line 14, we use the compare to method. And you see there on line 22, we're calling arrays dot sort again, but the second parameter, we're passing in that comparator object. If we go new circle comparator, we just wrote that comparator object class. Okay, so we don't need to save it. We don't need to save the object. We just pass it as the second parameter. And now arrays dot sort will use the rule defined in the comparator, which is the smaller the radius, the larger the circle object. So now let's just run this thing and see what happens. Yeah, so the first time, so we first remember we had that array of circle objects where the you know the radiuses are in kind of random order 8, 6, 100, 2, and then we sorted. So then it should be in ascending order by radius 2, 6, 8, 100, and that's oh let me run it again. I got rid of my output. Right. So yeah. So the first time we sort it, we're sorting by it's the bigger the radius, the bigger the object. So we always go from smallest to biggest. So the radius, the circle with radius 2 is the smallest. So we go 2, 6, 8, 100. And the second time we're using the rule defined in the comparator where the smaller the radius, the larger the object. So the larger radius is the smaller object. So notice how we first print out radius 100. So the circle with radius 100 is actually considered to be the smallest circle object. But the important thing to understand here is that it's just this comparator allows us to write, allows us to sort order objects from the same class. Even if the underlying class doesn't implement comparable, or if it doesn't implement comparable, we can override the rule in the compare to method. So that's all there really is to it. I think I might have another example here. So yeah, so like here, what is in this string? Let's just look at this one right here. I haven't put this online yet, but I will. I wrote this last year. I forgot that I had it here. I hope this isn't too small to read. So the string class orders strings in its, by alphabetical order, by dictionary ordering. Just like the A's and then the B's. Like you first compare the first character. If they're the same, then you compare the second characters. If they're the same, the third character, and so forth. Okay, so the string class, the compare to method in the string class compares using dictionary ordering. Okay, so let's say we wanted a different rule for comparing strings, and we came with this kind of, I don't know if that's how useful this is, but it's just an example. Let's say we want to order by length. We're going to order strings by length. We don't like this built-in method in the string class. So we write this class. The whole point of this class is to implement comparator because we need that compare method. So public class string comparator implements comparator. The generic variable is string, which means we're going to compare two strings, right? That compare method takes two parameters. We're going to compare two strings, and we're just taking the difference of their length. And in this case, this returns a positive value when the length of string 2 is smaller than the length of string 1. Okay, so string 1 is greater than string 2 if the length of string 1 is greater than the length of string 2. Yeah, so if string 1 has a greater length, this is going to return a positive value. So now let's just look at this test class. And so let me just move this down. Okay, so I can see it's getting blocked by Zoom. Okay, so like on line 13, we define a bunch of I'm gonna just comment. I haven't talked about this yet. Okay, so we have an array of strings. We're going to display them in the original order, and then we're going to sort using the compare to method in the string class, which would be sorting in alphabetical order. And then the second one, we're going to sort by the length of the array, length of the string. Okay, so let's look at this. Yeah, so display there we have the original order, then we use dictionary ordering, right? C, D, H, I, X. And then I say display from smallest to largest length. So is the smallest, 2 characters. And then the 2 strings of length 3. And then the string of length 5, and then xylophone is what? Length 9. It's pretty wild. I mean, you can just add to that if you want. Maybe let's add one more. How about, I don't know. Or it should come after dog. Let's see here. This alphabetical ordering. And in length ordering too. Okay, so yeah. So yeah, so and you can see that well, maybe that door was in an interesting place. Didn't really seem to change the order. Just move it. I'm not sure I'm sharing. Am I sharing this? What happened here? I thought I was sharing the screen. What happened?
I think you're still recording.
Oh, I'm still sharing. I'm still sharing. Yeah, the stop share went away. I didn't see it. Okay, I thought I was. I forget, a lot of times I do forget to share the screen. I just go to a new file. Okay, so let's see here. Okay, what now? Okay, why? Okay, what did my what did I do? Oh, here. After do. Okay, there's no. Okay, okay, that's better. Okay, so I had decided to put door first. I messed it up. And okay, now let's just run it again. Yeah, so we see the doors first, right, in the original order, and then it gets sorted. It goes after dog, and then it actually goes. Yeah, it still goes. Yeah, I probably should have picked something maybe to 4 characters, but when we're sorting it by length, yeah, it goes between dog and house again. So okay, but yeah, but what we saw, but the important thing here is I won't keep going on and changing it. The important thing here is that we can actually, by using Comparator, we can come up with our new rules to order things, which you do see all the time. Like you go to an e-commerce website, we can order by price or by price, or what else can you do? I forgot now. If like it's a book, you can do alphabetical order by author, or maybe the name of the book, or by price, and we can go from cheapest to small, most expensive to least expensive, and vice versa. So there's different ways of ordering a list. So Comparator gives us that ability to sort any kind of an array of any kind of object. Now let me just show you one last thing here, and then here I'll show you that string Comparator 2. It actually compared the strings in descending order, right? If string, see, I multiplied that by -1. So if string 1, the length of string 1 is greater than the length of string 2, we actually get a negative value. So yeah, so compare strings. So if the compare method returns a negative value, the first argument is less than the second argument. Okay, so let's just run this again, and we'll now uncomment this. See, now we're hello. Oh yeah, that's right. So the second time, you can see there on line 30, we're using a new we're using a different comparator. So you can use as many different comparators as you want, because you have to write the class. And now, so now it should go, the largest length should be considered the smallest string object. And that's what we get, right? So the last time, because we're using string Comparator 2, returns a positive value when the smallest length is the first argument. Or the string with the smallest length is the first argument. So it's a little bit fast, but I'll just show you one more kind of bonus thing while you're here, and then I'll see if you have any questions about anything. Okay, so test. One thing I'll just say here is that there's something called the lambda expression. Here, let me just, I'm going to comment this out. I'm just going to do, there's something called let me comment this out. There's something called a lambda expression. And maybe I'll talk about this later on. This is just kind of a preview. And it's a really very easy way of creating comparators. So we don't actually have to write a whole class. See how oh, every time I write a new comparator, I have to create a new class, right? Because you can only have one compare method. But let's say we don't actually want to write a class for every comparator. There's something called lambda expression. There's this whole area of computer programming called functional programming. It's kind of related to this. And most languages have this, like a Python has it. So arrays.sort. And so we're using that sort built-in sort method. So the first argument is always the array name, and then the second argument is going to be the comparator. So all I'm going to do, all this the lambda expression does is pretty much contain the parameter list. It contains the parameter list for compare, and then what's after the return statement. So let's go here. So the parameter list takes two variables. We can call them anything we want. So I put them inside because there's two parameters. So I put them inside parentheses. That arrow means lambda expression. And then we're going to go we're going to compare by length. So a dot length minus b dot length. Okay, and so how does it, see, we don't actually see in line 26, we're not saying the data type for A and B, but we're trying to sort an array of strings. So it's implicit that A and B are strings. And what we're doing is just taking the difference of their length, and that value is, that difference is positive when the length of A is greater than the length of B. So A is greater than B when the length of A is greater than the length of B, right? So when the return value is positive, A is greater than B. So now so we don't even need that string comparator class. Let's just run this. Now, so let me try that one more time. Let's get this out of here so it's not confusing. So we're just using the comparator. So we're just gonna, we won't use both comparators. Okay, so yeah, so display the original. Oh yeah, okay. What did I do? Okay, okay. I messed. We'll do one more time and then okay. So, yes. So that was not the smartest yet. This is what I want. This is what I want. Okay. Now, okay, one more time. This should work. Okay. So we're going to do dictionary ordering and then ordering by length using my lambda expression. Yeah. So so when you go from so that's what that lambda expression did. It ordered from smallest length to largest length. It's all because of this, and it's pretty clever. It's not really a lot of coding. It's all because of this thing right here, a dot length minus b dot length. A is greater than b when that expression is positive. So there's all kinds of ways of, so with these lambda expressions, it makes it easy to create all different kinds of sorting rules, but I'll give a more formal lecture on lambda expression another time if we decide to use it. So that's all it is, a kind of a fast lecture on comparator. But is there, do you have any questions, Julio, on anything?
No, it's very similar to comparable, the other one that we learned, right?
Right, yeah, it absolutely is, except now we have to use two parameters. So it allows us to override the rule in compare to. So we'll probably use this in an assignment at some point. And I'll ask students maybe to look at this lecture or something, and also on my notes. It's really not that hard to, students catch on pretty quick to this because there's not a lot of moving parts to this. And the next time we'll do something more kind of complex, and that's the quick sort algorithm. I just want everyone to be finished with their tests or whatever.
Yeah, it all seemed pretty similar, but.
So well, I'll stay here until you have no more questions, or I'll be the last one to leave the room.
Oh, okay. That was the whole lecture. All right.
Yeah, it's really not. Yeah, I didn't want to introduce any new material until after the test was due.
Oh, okay. I should probably go take that then.
Yeah, well, if you haven't done it, yeah, definitely start now. So you don't, because in my other class, my Math 130 class, I had a quiz due yesterday, and a lot of the students started at the last minute, and they couldn't finish it because time ran out. They did like the first half, and I go, oh, and then I looked at when they submitted it. It was like a couple minutes before midnight. So.
Okay, yeah, I was just waiting to go over the material, but yeah, I'll probably start that soon.
Okay, well, if you have any concerns or questions, just contact me.
All right, thank you.
Okay, talk to you later, Julio.